In a parallelogram ABCD, the diagonals bisect each other at point P. For some origin of reference O, we need to verify that OA vector plus OB vector plus OC vector plus OD vector equals to 4 times OP vector. Okay, let's try to understand this with the help of a diagram. So here we are considering a parallelogram ABCD. Now here, AC and BD are the two diagonals of this parallelogram, which are intersecting at the point P. Now we're going to consider some origin of reference O. Now with respect to this particular origin, what we'll do, we are going to join the vertices A, B, C and D as well as the point P of the parallelogram with the help of a directed line segment. So here we have the position vectors OA vector, OB, OC, OD as well as OP vector. Now we're going to define the position vector OA as A vector. Then we can define OB vector, the position vector of vertex B, with the vector B. OC vector will be denoted by the vector C and OD vector will be denoted by the vector D. Now using these four vectors, we can define the position vector of point P with the reasoning that P divides AC, the diagonal AC of the parallelogram, into ratio 1:1 internally. And that means we can define the position vector of point P as OP vector. That will be equals to, since we are considering the points A and C, so we will take the sum of the position vector of vertices A and C. So we have A vector plus C vector and divide it by 2. Fine. Now, the point P, the same point P, also divides the other diagonal BD into ratio 1:1. So here also we can apply the internal section formula to define the position vector of OP in terms of the position vector of B and D. So now that we have OP vector defined in terms of the endpoints of the diagonal AB, AC and BD, now let's come to the left hand side of the given equation. So we have OA vector added to OB vector plus OC vector added to OD vector. Now what we can do, we can combine OA vector and OC vector. We're going to combine OA vector with OC vector, and then we're going to separately combine OB vector with OD vector. Now OA vector, that's simply the vector A, and OC is the vector C. This will be added to OB plus OD, so that means we have B vector added to D vector. Now what we'll do, we're going to divide and multiply with the factor 2. So we have 2 times A vector plus C vector whole divided by 2. So we'll get added to 2 times B vector plus D vector whole divided by 2. Fine. Now we have already defined A vector plus C vector. So this is going to be the vector OP. And we have 2 times B vector plus D vector, so that's OP vector as well. So this is going to give us 4 times OP vector, which is the expression on the right hand side. So here we have successfully showed that the left hand side of the expression equals the right hand side, hence proved. Okay, however, I made a small mistake. Let me clarify that. So here, since P divides BD internally into ratio, so this is not A vector plus D vector, this is B vector added to D vector whole divided by 2.